We have now arrived at question number 5, and what are we doing? Let me say it again. We are practicing past paper questions on the topic work, energy and power. So if you look at the question, this question looks quite different from the kind of the questions we have done so far. So it's going to be a good practice, which is good for us. Getting a variety of different kind of questions to practice is always a good thing, so that you do not get surprised or shocked when you see such kind of questions in the question paper finally in your final exams. So here you have the question. You can pause the screen here for a moment, try to attempt the question yourself, and then I'll show you the second part of the question as well. It's not a very long question. All right. So this is the second screen of the question. And as I always say, and as I always request, please do subscribe to the channel if you think that the content on the channel are really useful to you, and if you're finding that the videos are helping you to improve your scores, then please do like the videos as well. And please do stay connected with me in the comment section. Type in your queries in the comment section. Type in your alternate ways of doing the same question which I am doing here in the videos. If you have some alternate ways of doing your questions, do share it in the comment box so that I can also learn from you. So here we are. I believe that you have solved the question now and you're back now to understand and verify your answers. So the first part of the question says, explain what is meant by gravitational potential energy and kinetic energy. If you're just writing the formula here, it will be difficult for you to score full marks because they are telling you to define these two terms. How Cambridge expects you to define gravitational potential energy and kinetic energy, please make a note of it so that you do not make mistakes in the final exam and you learn what is the correct way, what Cambridge expects you to write about these definitions. Gravitational potential energy is the energy of a mass due to its position in gravitational field, and kinetic energy is the energy due to the motion, speed or velocity. You can use any of these three terms. You don't have to use all the three terms. Understand these two statements. Make a note of it in your notebooks to understand how you define these two terms. Very, very important you define them this way. That's exactly precisely how Cambridge expects you to write the definition. There is no other way, right? If there is no other way, that means you have to spend some time to memorize it. Now let's come here and understand the second part of the question. A ball of mass 400 grams is thrown with an initial velocity of 30 meters per second at an angle of 45 degrees to the horizontal as shown in this figure. So there is a projectile motion that you see here. The air resistance is negligible. The ball reaches a maximum height h after a time is also given 2.16 seconds. Calculate the kinetic energy of the ball. They are telling you to calculate the kinetic energy of the ball. So what should be the kinetic energy? What is the formula for the kinetic energy? Kinetic energy is half mv squared. So half times what is the mass of the ball? 400 grams. Are you required to do something here? Yes, everything has to go in the formula in SI unit. So you'll have to change grams into kilograms. So which becomes 0.4 kilograms times the velocity. Velocity is 30. Solve it now. It should not be a difficult work to do, and see if you're getting the correct answer. I'm leaving the calculation work for you. Same thing, 180 joules. So you should be getting 180 joules. So while working the question yourself, if you got the answer as 180, give yourself 3 marks here. 3 marks. See, such an easy question and 3 marks. It's easy to score, right? Now the next part, calculate the maximum height of the ball. How do you calculate the maximum height? You have to use one of the SUAT equations, one of the equations of motion. Which equation do you think makes sense? I'm going to use this equation. V square is equal to U square plus 2AS. I'm going to use this equation. You can also use the equation, the other equation that you can use is S is equal to UT plus half AT square, and see if there is any other Suvat equation also which applies here and gives you your answer. If you have any other equation apart from these two as well, if you can find, please do comment in the comment box and share it with everyone, share it with me, right? So maximum height. Height is vertical, so let us take all the components of the velocity in the vertical direction to input their values in this formula, because we are working with a height or a displacement which is vertical. So what is the initial vertical component of the velocity? Initial vertical component, let us call it U. Initial vertical component, it is 30 sine 45. What is the final vertical component? 0, because at the topmost point of a trajectory or a projectile motion, the vertical component becomes 0. That's a fundamental that you need to remember. At the topmost point, you only have the horizontal component, no vertical component, right? So let us input the values in the formula. Vertical component is 0, horizontal component is 30 sine of 45 degrees whole square plus, let me take plus only, 2 times acceleration is negative because acceleration is in the downward direction. Acceleration happens in the towards the surface of the earth, but here we are taking everything in the upward direction, everything in the upper direction as positive. So G, you'll have to convert it other way around. So when you convert G the other way around, it becomes minus G. So here you'll take 9.81 with a negative sign, so in between you'll have a negative sign here, times the height h. This is the height h that you have to calculate. So how much is the value of h? H will be 30 times sine of 45 is 2, 1 over under root 2, sorry, 1 over under root 2. So when you take a square of it, it becomes 2 to 9.81. Solve this. You'll have to find the missing variable, which is h. This calculation is easy. Do it and you should be getting your answer as 22.94, 22.9 something, around 22 something. Mark scheme has used some other formula, some other logic that also you can understand, right? And please do share in the comment box if you have your own way of finding the height, but make sure that the height is coming out to be 22.9 something, right? So this is done. Now this is not the last part, the third part, the gravitational potential energy of the ball at the height h. Easy and straightforward application of the formula, and they are giving 2 marks for this. So lucky for you. mgh. What is the mass? 0.4. G is 9.81. Height you know already, 22.94. Work it out and see if you are getting this answer, which is around 90 joules or 89.8. Let me take it as 90. If you have any doubts so far, please do let me know in the comment box. I'm proceeding now with the second part of the question, which is on the second screen. Determine the kinetic energy of the ball at the maximum height. You have to determine the kinetic energy at the maximum height. There are 2 ways of doing it. One of the ways is total energy that you started with. This is the total energy that you started with minus the potential energy, and the energy which you are left with is your kinetic energy at the maximum height. That's one way. That's one way. So this is the energy that you started with minus the potential energy that you had at the topmost point. So this gives you your answer of 90 joules. That's your answer. Or what else you can do? There's one more way. If you understand projectile motion well, you would also, you can also do it another way. Find the velocity at the topmost point. At the topmost point, you'll have only the horizontal component of the velocity. So what will be the horizontal component of the velocity? What will be the horizontal component of the velocity at the topmost point? The horizontal component does not change. 30 cos 45 degrees. Horizontal component stays the same everywhere, no matter where you are. The horizontal component is the same at all these points, right? Which is 30 cos 45 degrees. If you know the velocity at the topmost point, which is just the horizontal component, you can use the kinetic energy formula, which is half mv square, with v being this value. And see if you are getting the same answer. Let me know in the comment box. Alright. So this is done. It's just a 1 mark question. So why make things complicated for 1 mark by finding the horizontal component and using the kinetic energy formula, which will be a long calculation, to just gain 1 mark. So you can use this small subtraction logic using the law of conservation of energy. That is, the energy that you had at the starting point, the total energy that you had at the starting point should be equal to the total energy at the final point. So total energy at the start, so you can say total energy at the starting point was 180 joules, and total energy at the ending point would be, total energy at the starting point was the total kinetic energy, and total energy at the ending point was potential energy plus some kinetic energy which was left, right? So this kinetic energy is what you have to calculate. This is how you calculate this using the law of conservation of energy, which is an easier way of doing this question. Now the next part, explain why the kinetic energy of the ball at the maximum height is not 0. Simple and easy, I've already explained. Because there is a horizontal velocity or horizontal component of the velocity which is still existing. When you have the velocity, you have the kinetic energy. 1 mark question, you can explain it. I'll now open the mark scheme and keep it open for you all to understand the mark scheme as well, on how you can solve these questions in various alternate ways as well. So in the next video, we are going to take up the next questions. Stay connected to learn more on this topic.